Hello, fourth grade friends. If you missed our video today, our lesson during our Zoom chat, here is what you missed. So today we are talking about angles, and last week we started learning about angles a little bit, but we are going to focus on something a little different today, or a specific kind of angle. So the first thing I want to do is a little review. So I want to remind you that an angle is a geometric figure where two rays share a common endpoint. So just for review, these are rays. A ray starts at a vertice, which is a corner, and then goes up with a line that ends with an arrow. Out with a line ends with an arrow. And when you put two rays together, you end up with an angle. So just for another bit of review, an acute angle is less than 90 degrees. So here's an example of an acute angle. An obtuse angle is greater than 90 degrees, but less than 180 degrees. So here is an obtuse angle. It's a little bit bigger. We call these acute little angles because they're cute and little. This is obtuse. Think of it as a bigger angle. Then we have right angles. Right angles are a perfect 90 degrees, and remember they are a perfect corner. That's why we put that little square right in the corner to show us that these are a perfect corner, a perfect edge of 90 degrees. A straight angle is 180 degrees. And if you look at the straight angle, my friends, you notice that if we were to put the dot here, the two lines that are creating the straight angle are going out in opposite directions to make a flat line. So imagine it starts here, it's opening all the way up to make a flat line across, and a straight angle flat across is 180 degrees. In contrast, down here, we have zero angles. Zero angles have, here's their starting point, here is the first line. Let me get a different color just to make sure you understand this. And here's the starting point, here's the second angle. They are completely closed, so they don't open up to any degrees. They are completely closed up to 0 degrees. I'm gonna take that off just so you can see. Completely shut off so that they don't have any degrees in them, okay? They are 0 degrees at a 0 degree angle. It is a flat line that is closed as opposed to a straight angle, which is a flat line that is open all the way. Kind of think of a straight angle as a rainbow that opened up all the way. A zero angle is just flat shut. Today we have a new word that we're going to talk about, and our new word is interior angles. And an interior angle is the angle on an inside of a shape. So last week when we were talking about our pattern blocks and measuring the angles on the pattern blocks, the interior angles are the angles that are inside of those pattern blocks. So I have a question for you. My question is, how can we use right and straight angles to determine the interior measurements of the triangle? Any ideas? Well, the answer is, dun 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 dun, we can use pattern blocks. These pattern blocks are going to help us to measure our angles. So I'm going to flip over here onto our math page for the day. And when we are measuring this, what I want you guys to understand is that, let me get my writing tool out. Switch to my favorite color. Okay, when we are measuring these things, we're going to use this tool down here. We have a flat line down here which creates what? 180 degrees. Yes, that is a straight angle that is 180 degrees. And what about this straight line in the middle? What does that tell us about this angle and this angle? This one right here and this one right here. What are those equal to? You are correct if you just said that. They are each equal to 90 degrees. So we have 90 plus 90 gives us 180 altogether. So we're going to try and measure these different pattern blocks using these lines down here to see if they help us. And if you notice off to the side, I have different pattern blocks that we can use that are going to match up with the pattern blocks up here. So the first thing that we're going to check out is, let's try and measure number 3. Let's do number 3, which is the triangle. And if you look, we have an interior angle here, here, and here. All of our interior angles, if you remember, are inside of your shape. So I'm going to go ahead and I'm going to take one triangle and put it over here. And it's a little hard to see, sorry, but if you notice, that triangle that's right there, it's not matching up totally perfectly with either the 180 degrees over here or the 90 degrees over here. So I think that I might need to add a little bit more. What do you think? Okay, I'm gonna try and add another one in there. And this is where it gets tricky because I have to turn it. Is it matching up perfectly to 180? No. Is it matching up perfectly to 90? Still not. What do you think I need to add? If you said one more triangle, I think you might be right. Let's see. Oh, oh, oh. Do those line up perfectly? I'm going to erase this so you can see just how perfectly that matches up. So we have 3 triangles that we put together. And when we put those 3 triangles together, we know that they add up to a flat straight angle, which is equal to 180. So what I'm going to do is I'm going to do 180 over here divided by 1, 2, 3 angles. I'm sorry, 3 triangles. What is 180 divided by 3? Any ideas? If you said 60 degrees, you are correct. So what I'm going to do is I'm going to go back to my triangle over here. Ooh, sorry. I'm going to go back to my triangle over here, and I'm going to write that I have 60 degrees. Make sure you put the degree marker, 60 degrees and 60 degrees. Very, very good. All right. Let's go back down here, and remember this straight flat line gives us 180 degrees, and anything that's in here gives us 90 degrees. So the next thing I'm going to do, which I think would be easiest for me, is going to be doing number 5, which is the square. Because it looks to me, when I were to match up the square, if you were to predict, what do you think this is going to equal? Gonna drag my square over here. Does it match up perfectly? I would say so. I can see, knowing that this angle right here, that this angle is 90 degrees. I'm sorry, let me do that again. I can see, knowing that this angle is 90 degrees here, and this is 90 degrees here. That those 2 rays connect to make a 90-degree angle. I know that my square angle is 90 degrees. And I know that all angles in a square are equal, so that makes all of them equal to 90 degrees. Nice job. Okay. Erase, 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 erase. Okay, so the next thing that I want us to do, is take a look at, there, I'd like to get rid of you, thank you. Okay, so the next thing that I think will be the easiest for us to do is probably, I would say, this rhombus up on top, number 2, this larger rhombus. So the thing we need to notice about the rhombus, when we bring down the rhombus, is we have, if we're looking at it, I think I have to change my color for this one. If we look at the rhombus, we have 2 obtuse angles and 2 acute angles in our rhombus. So that means that we don't just have to measure one angle, we need to measure all of our angles in here. So what I'm going to do is bring down this rhombus. I'm going to erase those so they don't confuse us. I'm going to bring down the rhombus, and first we're going to measure the obtuse angle. So I'm going to line it up right there, and I'm going to decide what would go in here first. I think if I'm trying to think about this perfectly, I might put a triangle in there. Oh, does that fit? Or is there still some left from the rhombus? There's still a little bit left over from the rhombus. So I'm going to go back and look at my triangle. And I'm going to bring over a second triangle because I notice that there is a triangle in that shape. Oh, and if you look, those two triangles fit. I know they're it's a little hard to match them up perfectly, but we know that these two triangles would fit perfectly in here to make a rhombus. So what I need to remember when I'm working with this is that one angle over here, if I go back up and check, was equal to 60 degrees, right? So I'm going to bring 60 degrees down here. And now if I'm looking at the line that I see right here, it's cutting directly in half my triangle, right? So I know half of 60 is 30, and I know the other half left over would also be 30. So I'm going to solve this by coming over here and taking my 60, and I'm going to just erase this little guy so you don't get confused and think that that says 160. But I'm going to take this by doing 60 plus 30 plus another 30. And if I'm using my math skills to figure this out, I know 3 plus 3 is 6, 0 plus 0 is 0. So 60 plus 60, 6 plus 6 is equal to 12. 0 plus 0 is equal to 0. So I end up with 120 degrees. So I'm going to go back up here to my rhombus and label that this is 120 degrees here. And if this is 120 degrees, we know that the angle directly across from it is 120 degrees as well. So then what I need to figure out is what would be left that that would be left for my acute angle. So let me clear that off. I'm going to come down here. That's my obtuse angle. Going to erase. Okay, so I'm going to move these pieces off. Delete, and I'm going to turn this so now we're measuring the acute angle. And remember, I want to make it even, as flat as possible. And I'm going to put this over here. And I know from what I just solved that one triangle would fit in there perfectly. And if I go back up and review, one triangle corner is equal to 60 degrees. So I'm going to go back down here. I know then that this corner is equal to 60 degrees. So I go back up to my rhombus and I label it 60 degrees and 60 degrees. Nice job, you guys. I want you to take a second and look at these shapes and tell me what you think would be the best idea to do next. What do you think would be the best angle or pattern block that we should use to measure interior angles next? I think that the next thing I want to measure is the hexagon. So I'm not sure if you guys know this, but let me erase some of these guys for you. Sorry, thank you for being so patient with me. It is really difficult when we are trying to move these shapes around. But if I bring a hexagon down here, I know that on a normal hexagon, all of my sides are equal length. And I know my angles are all equal to each other. That is the definition of a hexagon. It has equal sides and equal angles, and it is a six-sided shape. So what I'm going to do is I'm going to bring over my hexagon and match it up right at that corner at the bottom and see what I can do to figure out the shape and the angles inside this hexagon. I haven't tried the square yet, so I'm gonna try the square and see. Well, that fits in there, but I still need some more. And I don't really see a shape that I know the answer to yet that I could use to measure the inside. So I'm gonna get rid of that square. So let me try a triangle. One triangle isn't enough, so I need a little more. And it looks to me like if I were to guess that I can fit another perfect triangle right here. So I'm gonna grab another triangle, and turn it, see if it fits in there. Looks to me like it fits perfectly. What about you guys? What do you think? Perfect fit? I'm trying my best with my Apple Pencil to get it to be a perfect fit. Well, I know that this angle of a triangle, all angles of a triangle are equal to what? 60 degrees. So I'm gonna come down here and I'm gonna mark that. Oops, sorry, I have 60 degrees and 60 degrees. And if I were to come over here and do some math, 60 plus 60 gives me an angle measure of 120. So I'm gonna bring that back over here, go up to my rhombus, to my hexagon and label, this is 120 degrees. 120, 120, 120. And I'm gonna look just to double check, do I have anything else that equals 120 I can use as a double check for this? Oh, I do, I have that rhombus right there. So I'm gonna scroll down here and I'm gonna bring in a rhombus to check and see if it fits. Oh, does that work? Let's check up here. It works down here when I'm mapping it up. Let's see if the right angle is working. I want it to be this angle right on the side. 120. Let's bring it over there. 120, it works. Nice job, you guys. So what should we do next? I think I want to try the trapezoid. I'm gonna try the trapezoid next. So I'm gonna bring down the trapezoid and I want you guys to really take notice when we are measuring the trapezoid here, our trapezoid up here is going this way, but when we bring it down to measure, we are measuring it this way. So we need to make sure that when we are writing our angles up there, we don't mix them up. So I'm gonna start with the acute angle in the trapezoid. I'm gonna bring it right down here, and it certainly looks to me like I can fit one triangle in there. And I know that one triangle has an angle has a degree of, one angle of a triangle has a degree of 60 degrees. So I'm gonna put, remember we're working with these two angles first, okay? 60 degrees and 60 degrees. Nice job. So now I need to figure out the obtuse angle. So I'm gonna turn it so that I'm looking at the obtuse angle now. Gotta go a little bit more so that it's flat. Okay, there we go. And put it right in that corner. Right in that corner, that's where you need to be measuring, lining it up with that corner and the flat line on the bottom. That's how you need to measure all of these angles. So if I'm looking over here, what do I want to do first? I think I'm going to do, I know that a triangle fit in the small angle. Oh, and it looks to me like I can probably fit a second triangle in there if I wanted to check. Looks like it fits pretty well to me. What do you guys think? And I know that this is 60 degrees plus 60 degrees, which we solved earlier, is equal to 120 degrees. 120 degrees. And if I go up here, I can see, oh, my hexagon was 120 degrees. So I can use one of my hexagon angles to check and see if that matches. What do you think? Does it match? I think it matches perfectly. Beauteous. We did it, you guys. All right. So our last friend that we have left to measure, which I think is the hardest shape to measure in this entire page, is this little teeny tiny small rhombus, number 6, okay? So what I'm gonna do is I'm gonna come down here and bring over my small rhombus, and I am going to line up, remember, line up the corner right there at the where the corner would be to see if it's a right angle, and I can tell already that it's overlapping a little bit with a right angle. So I'm gonna put a square in there because I know a square makes a perfect right angle, but I can tell that I have a little bit of extra space I need to fill over there. What shape do you think is gonna fit in there? Looks kind of to me like it might be a triangle, so let's try that. Let's see if we can fit a triangle in there. What do you think? It looks like it's working to me. So I'm gonna go ahead and say that I have 90 degrees from that square and 60 degrees from that triangle, right? So come over here and solve. What is 90 plus 60? Well, that is equal to 9 plus 6 is 15. 0 plus 0 is equal to, sorry. 0 plus 0 is equal to 0. Hello. And remember, this is our last shape, so I saved the last one, the hardest for last. So we know that the obtuse angles in here are equal to 150 degrees. 150 degrees. So our last two angles that we need to measure, I'm going to go down here. I can check and see what would be, I'm going to clear this off, the easiest way to measure these, okay? So I could try, do you guys think I can fit a triangle back in there? Oh, looks to me like that's going to be too big. Can you think of any shape that would fit in there? I think maybe if we brought down a second rhombus, it would fit in there. What do you think? Does it make the flat line? When I connect those two pieces, does it go all the way over to make a flat line? It certainly does. So if I know this is equal to 150, I know 150 plus something is going to get me that flat line of 180 degrees. What plus 150 would get me to 180? If you said 30 degrees, you are correct, Amundo. 30 degrees and 30 degrees. Now, the last bit of information that I want to give you that's going to help you when you are working with these pattern blocks. The first thing I want you to know is that quadrilaterals, when you are working with quadrilaterals, sorry, these turned out kind of weird, I don't know why. All interior angles add up to 180, I'm sorry, not 180, they add up to 360 degrees, okay? And when you are working with triangles, all of your interior angles for triangles, all interior angles add up to 180 degrees. So if we wanted to check our work over here, a quadrilateral, 4 sides, 90 plus 90 plus 90 plus 90, that adds up to 360. 90 plus 90 plus 90 plus 90. I have 180, 180. 180 plus 180 is 360. And if I come over here for the triangle, 60 plus 60 plus 60 should equal 180 degrees. So these tools should help you. If you still have questions, remember that I will be on my office hours through Google Meet later this afternoon. Good luck. Bye.